Now that we've looked at a recap of what three-figure bearings actually are and how to work with them a little bit, we need to now go on and use this to solve problems involving bearings and trigonometry. Now the idea with these questions is you're going to be given a diagram usually. It'll have some north lines on it to help us work out where our bearings are or what our angles are. And the idea is we want to try and get rid of the kind of bearing stuff fairly quickly and turn this in just a plain triangle with angles inside the triangle, as many as we can find, and as many sides as we can find. So let's have a look at the first example here. Two ships are 40 miles apart, so there's ship 1 and ship 2, and the 40 miles is already on the diagram. So this piece of information up here we don't need to do anything with at the moment. Ship 1 is on a bearing of 240 degrees from ship 2. Now the word from here is so important. From ship 2 means the bearing is measured from here, from this north line, and ship 1 being on a bearing from ship 2 means that this angle going around here is 240 degrees. So what I'm going to do is I'm going to mark that off and write that in. So we'll say around here in the red is 240 degrees. The other information I can take here is it tells me the harbour, which is marked up here with an H, is on a bearing of 048 from ship 1. So again, the word from here, look out for that. From ship 1 means I'm measuring the bearing from here, and the bearing of the harbour from there is 048. In other words, from here, the bearing to this line is 048, which translates to basically an angle in here of 48 degrees. So I can put that in too. Now at the moment, what you'll notice is I don't actually have any of the internal angles of the triangle, which is what I'm going to need in order to do trigonometry. So we're going to continue to look at the information we're given here. Harbour is on a bearing of 048 from ship 1, we've dealt with that, and 315 degrees from ship 2. So it's basically saying harbour is on a bearing of 315 from ship 2. So again, from ship 2 means I'm measuring from here, and it's 315 degrees round to the line pointing towards the harbour. So we'll put this in a different colour. This angle going round here is 315 degrees. And that should help us to fill in at least one angle. Because if I've got the angle here is 240, but the angle here is 315, then how much further has this blue line gone than this red line? So this is an extra, well, let's see, it's 315, take away 240, which is 75. So that means I now have one of the angles inside the triangle. So I'm going to use a black pen here and stick that angle in here, 75 degrees in there. And that might help me then go on and find some of the other angles. So one of the angles rules that we looked at and we said was quite important was the idea of co-interior angles. If you remember back, and I'll just draw it up at the top right here, this idea that if I have two north lines and they are joined by a straight line, then the two angles in here should always add to 180 degrees. Now looking at this, if I know that I have 240 degrees round to here, then what's the angle from there round to here going to be? So the angle from here to here will be 360 minus 240. Now 360 minus 240 is 120, which means this total angle here is 120 degrees. Now, if this is 120 and this angle must add to 180, if that's 120, that means that this must be a total of 60 degrees. If I know this is a total of 60 degrees, then I can subtract the 48 from that 60 to find this angle in here, which is going to be then 12 degrees, and I can mark that off. Now I have two angles inside the triangle, which means I can go on and find the third one. So I can add together the 12 and the 75, which is going to give me, let's just do a bit of working up at the side here, 12 plus 75 is going to give me 87, and I can subtract that from 180, so 180 take away 87. Again, I'm going to borrow from there, that's going to give me 3, I'm going to borrow from here, and that's going to give me 17 take away 8, which is 9, so that's going to give me 93 degrees, which I can fill in up there. Now I have all three of the internal angles, and I have this length on the outside. Now this diagram at the moment is quite complex. The question is saying how far is ship 2 from the harbour. Now ship 2 is here, the harbour is here. This is the length I'm trying to find. So what I'm going to do is I'm going to mark off an X there. And as I was saying, this diagram is a bit messy now because I've got all these external angles and bearings and things I don't actually need anymore. So the very first thing I'm going to do at this stage is I'm going to redraw that triangle underneath and just take the information that I think I'm actually going to need. So I need the x because that's the angle I'm trying to find, and I need the internal angles, so the 75, the 93 and the 12, so we'll put them in. So 93 at the top, 75 down here, and 12 degrees in there, and I'm going to need this other side here, 40. You'll notice I'm not taking anything else. There's lots of information up there that I'm just leaving behind. This is all of the information I need to actually find x. Now, this is going to be a sine or cosine rule question, so I've got to identify which one. I'm looking for a side. So the first thing I'm going to look for is, do I have the opposite angle? So I'm going to draw this arrow in here. And then as normal, I'm going to look and see if I can find another side to angle pair. In other words, another side and angle opposite each other. And if I look here, then I have one there. Now, what that gives me is it gives me an idea that this is going to be a sine rule question. Anytime I've got these crossing arrows like this, it means it's sine rule, and it's sine rule to find a side. So that's A over sine A equals B over sine B, which means, and we're going to put in our side we're looking for up at the top here. So that's going to be x over sine of the angle, and use my arrow there. The x is joined to 12 degrees, so sine of 12. And then over here, I've got my other side, which is going to be 40, and my other angle, which is the one opposite at 93. So it's going to be equal to 40 over sine 93. Now, to get the x completely on its own, I'm going to multiply both sides by this sine 12. So x equals 40 sine 12 over sine 93, which I'm going to then type into a calculator, and I should end up with 8.34. And the answer here is in miles to match the unit of the question. Okay, so again, just a quick recap. What we're trying to do is use the information we're given about the bearings, kind of draw them onto the diagram, but the purpose of doing that is to try and find as many internal angles of the triangle as we possibly can. Once we've got those internal angles, what we do is we redraw the triangle to make it a little bit simpler and a little bit less confusing. Basically, this as a diagram is quite hard to work with. It's lots of numbers, whereas we just take the information we need and it makes it easier to then do our calculations. In this example here, again, we are dealing with bearings, so we're going to look at the information we're given and see if we can translate that across to this diagram over here. Now, there is a diagram here, but it's only kind of partially drawn at the moment. So the diagram shows the position of two walkers, walker 1 and walker 2. So there's walker 1 and walker 2. Walker 1 left camp, so we'll actually need to maybe put a little C on here for camp. So we'll pop a C at the bottom of that diagram there. So walker 1 left camp and walked on a bearing of 042 for 6 miles. So this line here from camp to where walker 1 is now is 6 miles, so we can put that on. And we can also maybe look at the bearing here. So he walked on a bearing of 042. Now remember, bearings are always measured from north and they're measured clockwise. So that means that the bearing of 042 means that this angle is 42 degrees in there. Okay, basically from here to here. The next thing is walker 2. He left camp and walked on a bearing of 115. We'll come back to that. And he walked for 5 miles. So let's just put the 5 miles down here. So 5 miles for walker 2 from his walk, or her walk, from camp to here. And the bearing they walked on was a bearing of 115. Now remember again, bearings always measured from north and always measured clockwise. So from north clockwise, that's 115 degrees around there. Now I can again put that on. I'm going to use a different colour. This angle here is 115 degrees. The question is, how far apart are walker 1 and walker 2 now? So how far apart are these two? Which means I'm going to need to put an extra line on here. So I'm going to draw a line joining walker 1 and walker 2, and I'm going to put an X on it. Looking at this diagram, I don't quite have enough information because even though I've got two sides and I'm looking for a third side, I don't have any of the interior angles of the triangle worked out yet, which I am going to need. So if the bearing from here to here is 042, so this angle is 42, and this angle is 115, then I should be able to work out this angle as being the difference between 115 and 42. So I can calculate that, 115, take away 42, 42, remember you'll have a calculator for this, I don't know why I'm doing it with a bit of work in here. Borrow that and we end up with 7, and we end up with 73 degrees there, which I can put in here. And then again, don't leave your diagram like this. and then try and do the trig stuff. Just take a bit of time. It'll always make life easier. Just quickly sketch out the triangle on its own. Just a rough sketch. 5 miles there. 6 miles here. And x on the side you're trying to find, and the angle that we know in the inside. That's the only angle I can find here. Now, for this one again, sine rule or cosine rule, I kind of know which one it is, but just as a method to find out which one it is, if you're looking for a side, first thing you do is check, do you have the opposite angle, and try and draw that arrow in if you do. So I'm going to draw that arrow in there, and then I look for another side to angle pair. Now I've got this side, but opposite that there's no angle, so I can't draw an arrow here. And I've got this side, but opposite that there's no angle, so I can't draw an arrow here. So anytime I just get the one arrow, then it means I'm going to use cosine rule here. So cosine rule to find a side is a squared equals b squared plus c squared minus 2bc cos capital A. Remember when you're doing this, if you're looking for a side, that's small a, then capital A is the angle opposite the side you're looking for. So remember that when you're filling this in. So that's x squared equals, it doesn't matter which one of 6 and 5 you make b or c, so we'll just do it in any order. 6 squared plus 5 squared minus 2 times 6 times 5 times cos of the angle, which is 73 degrees. And then I'm going to take the right hand side of that and type it into a calculator. And I end up with 43.46 to 2 decimal places. Now again, even though I'm writing this to 2 decimal places here, I am going to keep the full value on the screen of my calculator, and when I come to take the square root of both sides, I'm not going to type in 43.46, I'm not going to use this rounded value, I'm going to use the value that's already on the screen of my calculator, which is more accurate. So x therefore equals the square root of 43.46, so we're taking the square root of both sides, and again x equals, now on your calculator, as I said, you should still have this full version of this number here, so type in square root of answer, and press equals, and you should end up with the accurate answer of 6.59, and this is in miles. And that's how I would tackle a question like that. So again, draw onto this, find as many internal angles of the triangle as you can, and add any information. For instance, sometimes you might need to add a line and the letter for the side you're trying to look for. But once you've done all that, always try and redraw a simpler diagram to help you focus on the actual trigonometry problem. We'll now go on to look at the last of these problems. So this time it's a slightly different problem, because this time you're asked to calculate the bearing, which means what I'm going to be trying to find at the end here is an angle. So we have 3 airports in the diagram: Talbot, Horton and Midas. So Talbot, Horton and Midas. Midas is 100 miles due south of Talbot. That information is shown there on the diagram. Talbot is 120 miles from Horton. Again, that is shown on the diagram already. So then we need to look to the next line. Horton is on a bearing of 040 from Midas. So again, the word from here is so important. It's from Midas, which means I'm talking about the bearing taking from this point here. And Horton is on a bearing of 040, which means the angle measured from the north line going up the way here to the line that leads to Horton is 040. So that angle in there will be 40 degrees, which means I can fill in one of the angles I'm looking for. It then doesn't really give me any other information. It then says calculate the bearing of Horton from Talbot. Now, what this means is I'm trying to find, again, the bearing of Horton from Talbot. So the word from Talbot, or the words from Talbot here, tell me the bearing I'm looking for is measured from this point here, and it's the bearing to Horton. So from the north line measuring around to the line pointing to Horton, I'm trying to find this angle in here. So I'm going to just put a little red line in there to remind myself that that's what I'm trying to find. And obviously this is a trigonometry problem. This angle here is not inside the triangle, so I can only use trigonometry at the moment to find angles inside the triangle, which means the angle I'm going to actually be looking for in this question is this one in here. The angle in here and the angle here, because they lie on this kind of north line, it's a straight line, so this angle and this angle should add up to 180 degrees. So let's put an x in there for the first thing I'm going to try and find, and then again I'm going to try and redraw that triangle if I can, just to make sure I've got all the information I need. Now this is quite a tricky question in the end, so I'm going to draw the triangle out quickly, and then we'll fill in the values we have. So let's see, we've got 120 miles here, we've got 100 miles here, and we know that we're looking for x, and we know we're looking for this 40 degrees here. Now, again, when you've got a trigonometry problem and you're looking for an angle, the very first thing I'd be checking is, do I have the opposite side? Now, if I look at this, there is no length given here, so that's a problem straight away. When you're not given the opposite side or the opposite angle at the start of a trig problem like this, you kind of need to use the fact that angles in a triangle always add up to 180 degrees. Now in this case, that means because I can't actually find this angle directly because I don't have the opposite side, then I need to think about a different way of getting there. So what I'm going to do is I'm actually going to go and find this angle instead, and then once I've found this angle, I'll have two angles in the triangle and I'll be able to work out the third one. So I'm going to choose a different letter here. I'm going to call this angle Y, and again, when I'm looking to find an angle, I must check if I've got the opposite side. So now I do have a situation where I can draw that arrow in, so that Y is opposite the 100 miles, and then I'm trying to find another side to angle pairing. So that 40 and that 120, they go together. And because I've got these crossing arrows, that means it's a sine rule question. So sine rule to find an angle is sine A over A equals sine B over B. Remember, we invert the formula or turn it upside down when we're looking for an angle. So let's start to fill that in. Remember, we're trying to find angle Y here, so we're going to use Y there. And the side opposite the Y is the 100, so the 100 will go at the bottom. So it's going to be sine of Y over 100 equals, and again, over here we've got sine of B, so it's the other angle in the question, which is the 40, and the 40 is opposite the 120, so sine of 40 over 120 is going to go over here. And then we're going to multiply both sides by 100, so sine Y equals 100 times sine 40, all divided by 120. And I'm going to put that into my calculator to get a value for sine Y. And I end up with 0.5357. Now that's to 4 decimal places. Remember, I'm going to try and use the actual value on the screen in my calculator anyway. So this is a trig question, so it requires a cast diagram. And we are going to look at sine being positive, so sine of Y is positive values all in sine. But if I look at this diagram here, we can see quite clearly that Y is an acute angle. Now if Y is an acute angle, we can actually just get rid of this part of our cast diagram here. Remember, sometimes when you're doing sine rule, you can potentially get two solutions and both solutions be valid, but in this case we can get rid of the non-acute angles. So what we're going to do is find inverse sine of 0.5357. Again, remember, I'm not going to use that or type that into my calculator. I'm going to use the value that's already on the screen of my calculator, which is more accurate. So inverse sine of answer, and that gives me 32, let's say 32.4 degrees. So equal to 32.4 degrees. That means that Y is equal to 32.4 degrees in this case, because the quadrant I've ticked here is just the acute angle one, so this is my solution. Now what that does is it gives me this value here, which means I now have enough information to find this value here. So I'm going to take the two angles I know, which are 40 and Y, and add them together. So that's 40 plus 32.4, which is going to be 72.4 degrees. So that's the angles we have so far, and I'm going to then subtract that from 180 degrees. So 180 take away 72.4, and that's going to give me 107.6 degrees. And that gives me the value then for X. So I add together the two that I know, and then use that to find the third one. So therefore X is equal to 107.6 degrees. Now that's not the question. Always go back and have a read. So we are asked in this question, remember, to calculate the bearing of Horton from Talbot, and at the start we marked it off with this little red curve here. That's the angle we're trying to find. Now X and this angle here, these must add to 180 degrees. So all I've got to do is subtract X from 180, or subtract this value here from 180, and that will give me the angle that's going to go in here. So let's say that's 180 take away 107.6. We don't need a calculator for this, we've effectively already done that above. So 180 take away 72.4 is 107.6. Therefore 180 take away that must be 72.4. And what we're going to do is say, well, if this angle here is 72.4 degrees, because we want to have it as a three-figure bearing, we're going to drop that extra decimal point there, and we're going to write it as a three-figure bearing. So we're going to say the bearing is 072 degrees.